gravity-defying speed records.
When you're really racing hard, it's about like a 5-round fight where you're getting beat up a whole lot.
Life-threatening stunts.
I actually came out of the hospital about 3 inches shorter than I was before I took off on that flight.
And the world's fastest motorsport.
To watch someone who flies a space shuttle come back from an air race with his knees knocking, it's just so different than any other experience that you've been involved with.
When breakthrough engineering fuels impossible speeds, only high-tech innovations keep fearless flyers alive.
The fire was 20 lengths longer than the airplane was. If you'd ever seen it on a movie, you'd say it was fake.
And push the crash science of extreme aviation. Nosedives, flaming explosions, backbreaking bailouts. For the world's most daring pilots, phenomenal feats can end in devastating disasters. For engineers, a safe landing is the ultimate challenge, driving aviation design and technology to new heights. Still, in some of the riskiest flying on Earth, pilots test the odds of survival, pushing each other and their planes to the breaking point.
Head to the hills! Head to the hills!
Whoa, man.
Daredevil pilots master aerobatic stunts, but a sudden breakdown can send a pro into a lethal nosedive, and survival can come down to groundbreaking engine design, as flyer Wayne Handley discovered in a plunge that nearly took his life.
I was going to hit the ground, I was going to hit the ground hard.
October 1999. Wayne Handley joins top pilots at the Salinas, California International Air Show. Aerobatic pilots perform awe-inspiring aerial stunts, some of the most difficult airborne maneuvers in the world.
I like to be able to tumble the airplane. It took me about 2 years to teach myself how to do that maneuver. What I like best is inventing new maneuvers. Experimenting, kind of pushing the envelope, finding new maneuvers, new techniques, refining old techniques and learning how to teach them. I get a kick out of that.
This weekend, Handley plans to execute a feat few flyers have ever accomplished. In less than 60 seconds, he'll take off and land in the same spot, facing the exact same direction, without laterally turning around in the air. To do it takes 2 stomach-churning loops.
And I would pull up over the top in a half cuban 8, which is 5/8 of a loop. Track backwards downwind a couple of seconds, then I would pull vertical, roll the airplane, push over, pull the airplane's propeller into reverse pitch so I could come down very steep.
Only an unusual plane could allow a pilot to pull off this master maneuver. Handley custom designed his Oracle Turbo Raven himself. From nose to tail, the Raven weighs less than the total amount of power or propeller thrust it can generate. For Wayne Handley, this extra power means he can seem to defy the laws of gravity, going from a vertical takeoff to standing still hovering in a dead stop in midair.
There's never been, to my knowledge, a civilian airplane other than a helicopter that could go vertical and stop and all.
Wayne, I'm ready if you are, and folks, get your camcorders handy because you're not going to believe the spectacular climb performance of this airplane. It's all yours, Wayne, let's go!
The crowd watches spellbound as Handley begins his stunt. Dramatically trailing smoke from an attached smoke machine, the pilot's in top form.
I was very confident, I was very comfortable. Life was good. Everything was going just fine. Everything was flowing.
Then, cresting at 1,400 feet, Handley begins the trick's steep descent. Suddenly, he plunges straight down. The crowd screams as Wayne Handley smashes into tarmac.
The impact was just crushing. I mean, it was just beyond what you can imagine, you know, as far as the impact itself.
Though briefly thrown up and out of the cockpit on landing, Handley miraculously survives, but the intense force takes its toll.
And with that compression, another compression up through my spine, I actually came out of the hospital about 3 inches shorter than I was before I took off on that flight.
What went wrong? Experienced pilots like Wayne Handley rarely fall out of the sky. Anxious to perform well, did Handley overlook early warning signs?
Everything was just as it should have been, right up to the point of where it wasn't the way it should have been.
Even stranger, Handley knew how his aircraft could survive almost any crash scenario. In a rare plane like the Turbo Raven, which has more power than weight, by changing the pitch or angle of the propellers, the plane could drastically slow itself down.
If I was coming down and wanted to make a very steep, slow descent, I could pull the propeller into reverse pitch. It was a fantastic speed brake, so I could come down very steep and not accelerate. That was a great feature of the airplane.
Yet something caused the Turbo Raven to nosedive. To understand the crash crisis point, we first have to examine how turboprop engines generate power, and one of their weakest, most dangerous links, the ignition.
It's just like your car, you know. You need fuel, you need ignition, you need RPM. I had the RPM, probably had the fuel, but didn't have the ignition.
Turboprop engines work by drawing in the outside air and compressing it, forcing the air into smaller and smaller compartments. This highly pressurized air then passes into a combustion chamber, where it mixes with fuel. Inside the chamber, a spark igniter lights the flammable air-fuel mixture. As these burning fumes expel under intense pressure, that pressure equals mechanical power, power used to turn the attached propeller. A turboprop engine can generate strong force, but lose its ignition spark for any reason, and the plane's in deadly danger.
And it's very similar to the igniter that you find on your backyard gas grill.
When the pilot light goes out, when there's no more combustion in there, you have no more thrust. There's no more power.
In pilot speak, losing an engine spark is called a flameout. For Wayne Handley, a flameout was his ultimate undoing.
But had never considered the possibility of an engine stop failure, a flameout, in this maneuver. Almost cost me my life. What caused the flameout of the engine, I guess now I'll never know.
What's the solution to preventing unexpected and life-threatening flameouts? To solve the problem, aviation engineers faced a huge hurdle, preventing an engine flame from ever extinguishing. In a system which relies on air compression, sealing the engine to avoid drafts would cause a combustion breakdown.
Gas turbine engines require a certain amount of airflow through the engine, and that airflow must be continuous and it must be undisturbed.
In addition, a plane like Handley's flies at extreme angles, against gravity. Steep aerial somersaults like his Salinas stunt can disrupt the steady flow of fuel to the engine. Even a flicker can bring a plane to a halt.
In the case of the aerobatic flight, abrupt maneuvers could cause the engine to flame out.
Rather than preventing flameouts, engineers turned their attention to relighting them. They created a continuous ignition. Like a spark plug, a continuous ignition sends an electrical current back and forth between two metal receivers, allowing the flame to reignite instantaneously. Plus, a continuous ignition runs on electricity, not fuel. In a crash crisis, this independence from the engine can mean the difference between life and death.
If you have continuous ignition in a turbine engine airplane, if something were to happen within the engine to cause the flame to go out, that igniter is still there and it's still operating. So it's going to reignite and you probably wouldn't even know that it went out.
Ironically, Handley's Turbo Raven had a continuous ignition, but the aerobatic flyer was focused on showmanship. A decision before the stunt had near fatal consequences.
The igniters would automatically start firing and they snap, they make a lot of noise. And being that narration from the cockpit was a big part of my entertainment package, I elected to run with the igniters not in continuous. And if I had been running with the ignition on continuous and it flamed out, but the fuel was all still there and all, it would have refired and started spooling up to some degree before I hit.
Today, another ignition solution can save Handley's dilemma and keep his plane in the sky. An automatic ignition. Using embedded sensors connected directly to the engine, an automatic ignition waits to read a sudden drop in engine power before turning itself on and generating the needed spark. By sparking only as needed, an automatic ignition saves electrical power, as well as wear and tear on the ignition system, making deadly flameouts even less likely to occur. Air racing. From the first official competition in 1909, this high-risk sport's become an obsession for fanatic fans and speed demon pilots. In air races, the fastest competition category is the unlimited class, ruled by souped-up World War II fighter planes called warbirds. It takes hundreds of thousands of dollars to transform colossal combat bombers like Corsairs, Mustangs, and Sea Furies into race plane powerhouses that can cut through the course at 500 miles an hour.
They're an amazing tribute to the human quest for speed. It's the fastest motorsport in the world, bar none.
But without warning, even the fastest plane can explode in the sky. For a pilot, survival can rely on the make-or-break technology of a fast exit, as one legendary pilot experienced in a near-lethal bailout.
No telling where the airplane would go once I jumped out of it.
March 1994. It's the first ever Phoenix 500, a challenging competition in the National Air Racing Circuit. Flyer Kevin Eldridge is a commercial airline pilot and warbird racer. This event, he's flying his Super Corsair fighter plane.
As far as racing the Super Corsair, it was a demanding airplane. Once you started racing and got your speed up, you were actually having to use two hands to fly it through the air. It was a real beast.
Like all piston planes, the Corsair's powered by a piston engine, in which mechanical rods pump inside cylinders to turn crankshafts connected to the propeller. In World War II, the Vought Aircraft Company's bent-wing Corsair earned a fearsome reputation as a machine gun bomber with an 11-1 victory record, and the first fighter plane to hit 400 miles an hour. But it took Eldridge and his build team to turn it into a one-of-a-kind Super Corsair.
We all built it from the ground up. We all put our sweat equity into it and built this airplane. We've been flying it for 12 years up to that point. It was a one-of-a-kind airplane.
To turn the heavy-duty combat carrier into a competitive racer, it had to become a lean, mean machine. That meant lose bulk and gain power. On the outside, the build team lopped 4 feet off the extra-wide bench-shaped wings.
These are full-length stock wings. So basically where that seam is on the wing up there is where we cut the wing off.
Inside, they boosted the Corsair's horsepower into the stratosphere. A strategic swap doubled the engine strength, literally.
The Super Corsair that we raced had a 28-cylinder, 4,000 horsepower engine. Instead of the engine being from here to here, it was actually from here all the way back to here.
The challenging course will put Eldridge and his rivals to the ultimate test. It's a 9-mile oval marked by 50-foot pylons. To cut race distance and flying time, pilots fly the course tight and low as possible, less than 2 minutes a lap, covering 2.5 football fields a second. Flying up to 500 miles an hour, the fastest pilots cinch the 7-lap race in little more than the time it takes to prepare for takeoff.
There is 8 of the fastest propeller-driven airplanes in the world.
Now, as the announcer signals a start, Kevin Eldridge and his 7 rivals enter the first lap. In this fast competition, every decision counts.
Up until that point, I was in second place behind the Sea Fury, just kind of finding my time to the right place to pass them on the course. Not pushing a lot of power, just kind of pacing them, as you might say, and just looking for a good spot.
Heading into lap 3, Eldridge's skill shows. Flying dangerously low on the course, he shaves precious flying time. In second place, he pushes for the lead. Then, Mayday. In a sudden burst, his Super Corsair plane shoots deadly flames. In the cockpit, Kevin Eldridge receives the urgent radio command no pilot wants to hear.
They told me I was on fire, and started telling me to bail out, jump out.
If you're in a fire, in a cockpit, flying an airplane, your chance of survival is really thin, narrow. So, from our seat, we told Kevin he needs to get out of it now.
Despite the shooting flames, the pilot hopes to avoid the jump and make an emergency landing, until a second surge of fire seals his fate.
The fire was 20 lengths longer than the airplane was. I mean, it was a Hollywood fire. It was the dumbest looking thing you'd ever seen, because if you'd ever seen it on a movie, you'd say it was fake. It was that intense.
Before he can bail out, Eldridge has a critical mission.
I knew I needed to get away from the airport and the crowd, because no telling where the airplane would go once I jumped out of it.
Trying to maximize time before making the jump, Eldridge takes the Super Corsair from 50 to 2,500 feet, attempting to exit the failing plane.
I ended up slipping off the seat and getting physically stuck in between the seat and the fuselage of the airplane. I broke my leg, and that actually freed it, and instead of getting a good jump out of the airplane, I actually just kind of flopped over the side of the airplane.
Finally out of the cockpit, the pilot's luck turns from bad to worse.
This is the horizontal stabilizer of the airplane. This is where I impacted on the exit of the Super Corsair, coming out of the left side of the airplane, and actually physically impacted with my arm here and my top of my head right there. That's what broke my neck and my arm.
As the plane slams to earth in a ball of fire, spectators spot the pilot's parachute. But they're unaware of a dangerous reality. It's Kevin Eldridge's first time jumping from an aircraft. Now, falling fast, his life or death struggle is far from over.
This 2-lane highway was behind me, and next thing I noticed is there's a white diesel truck coming, and it's gonna hit me. So I put my arms out at the last minute to get a little wind resistance, and it blew me right over the truck. I wasn't able to sit up. I had a broken neck and everything. So I just kind of waited there, and it took 15 minutes or so until a helicopter found me.
Treated at a local hospital for extensive spinal injuries, today, Kevin Eldridge is lucky to be alive. But what went wrong, turning a routine bailout into a spine-shattering catastrophe? The crash crisis first began when an unforeseen engine problem suddenly erupted into a combustive situation, with unlucky timing.
Probably had this internal flaw that was maybe never caught before, and it just, that time I decided to go.
But it's when he started to exit the plane that the real battle began, getting out alive. In the Corsair, The fuel tank sits between the engine and the cockpit. As the flames flickered closer, Kevin Eldridge was on borrowed time.
It's not like a car. If you're in a car on fire, you could pull over and open the door and get out. This is, that's just the beginning of your ordeal. Once you're trying to get out of the airplane, you still got to make it to the ground.
To understand the extreme danger of Kevin Eldridge's jump, we only have to compare it to an ideal bailout. To exit safely as they're bombarded by a powerful airstream, pilots must jump high and far enough to clear the fast-moving fuselage. The faster they're flying, the more this calculation is vital to survival. But in a monster mayday, it's geometry that can be tragically out of reach.
You have to position the seat height to where you can open the canopy first, climb on the seat, and then push off from the seat.
You got to have time to jettison the door or the canopy, time to unlatch the seat belt shoulder harness, exit the aircraft, and then get into a position to pull the D-ring. An appropriate speed would be as slow as you possibly can. The slower the speed, the better.
Plus, an earlier aerodynamic adjustment made a smooth bailout impossible. Trimming the Corsair's bulky wingspan made the plane faster, but less stable.
The aircraft would not fly straight and level. It wanted to roll to the right. And I had been trying to get in the seat to jump out of the left, and the airplane's trying to roll to the right, and all this is happening at once.
Now trapped in a flaming, unstable plane, each time Eldridge let go of the steering, the Corsair spun out of control, forcing him to eject with disastrous consequences. The solution to dangerous bailouts like Kevin Eldridge's? For decades, engineers wanted to make ejection safer. Their goal, a cockpit contraption which catapults a pilot out, still strapped to his seat, the ejection seat. At first, ejection seat technology used crude explosive charges to blast the pilot out. Then, early rocket-launched nozzles violently smashed the pilot through the canopy, the cockpit's transparent roof. Rough methods, which often did more harm than good.
The body's going to be put under a lot of pressure. That force is going to be moving the body upward, so it's going to have compression on the spine.
To combat damaging ejection seat force, modern engineers are pushing the technology to new horizons. One ingenious addition, mechanical extension rails. In a bailout, these telescoping rods first lift the pilot up out of the plane, strategically blowing open the canopy. From there, rocket launchers propel the pilot safely past the fuselage, clearing the falling plane.
When the pilot pulls the ejection handle, a catapult rocket will fire the seat away from the aircraft.
It's going to take that seat out of the aircraft and get it far enough away from the aircraft so the pilot can safely exit from the seat. And the pilot will float down via parachute and the seat will just fall.
Though not yet common in race planes, many military aircraft trust life-saving ejection seats. And future flyers like Kevin Eldridge may depend on them in the most perilous parachuting emergencies. In high-speed air racing, few catastrophes are more deadly than plane-on-plane collisions. When disaster strikes, only an extreme safety innovation can stop a pilot from paying the ultimate price.
At 450 miles an hour, the last thing you want to do is touch anybody with an airplane because it'd be catastrophic.
September 1994. Reno National Air Races. Skilled flyers Ralph Twombly and Jerry McDonald race in the T6 class. Single-engine World War II fighter pilot training planes, T6s are warbird workhorses packed with 600 horsepower engines hitting top speeds of 230 miles an hour. Unlike their unlimited class cousins, All T6 planes share identical construction, offering pilots a level playing field and close competition.
As far as T6s go, it's really hard to say what's special between one and the other because they're supposedly all stock in that class. So it's not that it was his airplane was special, but that class was pretty special.
As the Reno T6 class race gets underway, pilots jockey into the starting lap. Jerry McDonald, flying his popular T6, the number 5 Big Red, holds steady in the middle of the pack. Navigating a pass from above, rival Ralph Twombly moves closer into the race route. In a split second, the two planes make catastrophic contact.
Oh my God, oh my God.
Sustaining the worst of the damage, Ralph Twombly pitches upwards, losing vital pieces off his fuselage. Crippled and failing fast, Ralph Twombly spirals downwards, hitting ground with shattering impact, smashing into a nearby house. Signaling a mayday, Jerry McDonald manages to land his damaged plane off course. Though he's lost part of his wing, the pilot's uninjured. Rescue crews and firemen rush to the wreckage. With pieces of the plane strewn across the ground, the accident looks ominous.
Got airplanes out. Airplane down on the west end of the field.
At the crash site, rescuers find pilot Ralph Twombly dead. News of the tragedy rocks the close-knit racing community.
It's that sick feeling in the bottom of your stomach, and it's just, you know the outcome. And the more human part of that is if you go to Reno for any number of years, you probably know the guys out there in the airplanes, even if you're a fan.
What went wrong? Determined to overtake Jerry McDonald in the critical first lap, did the pilot push his T6 plane too far?
You could watch a guy like Ralph fly the pylons, and he would go by every single lap in the exact same place. His line was consistent every single time. He was very competitive. You could watch guys like Ralph fly and really appreciate their skills.
Yet something got the skilled pilot into deadly trouble. To unravel this crash crisis, we first have to examine the extreme risk of a race start and the geometry of a perilous passage called the chute. In air races like Reno, planes take off from a wide, straight line, heading into the start's first lap through a narrowing quarter-mile passage called the chute. In this flying start, every millisecond maneuver matters.
At this point is when a lot of guys might bank out to give themselves a little more room if everyone's too close. Some guys might go up or down a little bit. The chute is so difficult and probably the most dangerous part of racing.
As Ralph Twombly raced down the chute towards the start, the final piece of the crash puzzle came down to visibility.
If two airplanes come together, someone didn't see someone else, or both people didn't see each other.
Passing down from above, Ralph Twombly was unaware of Jerry McDonald's exact position. As he collided with his competitor, Ralph Twombly lost his tail rudder, decimating his plane's stability. With no way to keep himself level, Twombly flew upwards in the powerful airflow. As the doomed pilot flew against gravity at such high velocity, the force ripped the wing off his plane. Finally, as Twombly spiraled down, he was powerless to stop the disaster that took his life.
Just the way the airplane tumbled through the air, and then everything, came down to the ground after that.
Here we go.
Can such horrific mid-air collisions be prevented? When visibility is severely compromised, One technology solution is to give pilots another way to sense an oncoming plane. In the past, radar offered pilots surveillance on other aircraft, but nothing gave them instantaneous plane-to-plane communication, vital information in an impending collision. The answer's found in a computer, a sophisticated sensor device called the Traffic Alert and Collision Avoidance System, or TCAS.
That's going to revolutionize aviation safety because it will minimize mid-air collisions and hopefully eliminate them.
Here's how TCAS works. To read an approaching aircraft's position, altitude, and oncoming speed, each plane carries a transponder, an embedded sensor which simultaneously sends and receives information. With TCAS, as planes fly within each other's transponder range, they automatically bounce signals back and forth, allowing the pilot to change course to avoid catastrophe. Even more remarkable, if planes fly too close for any reason, TCAS sends an urgent verbal warning with life-saving instructions.
Descend! Descend now!
What the pilot sees, very similar to what a radar operator would see at an air traffic control site.
Climb and maintain 1-2000.
We're going to be able to see the altitude and direction of the aircraft. If the aircraft gets too close, the first thing the system is going to tell us is that we have traffic. If for some reason that traffic gets closer, then it's going to go into resolution advisory mode, and it's going to tell the pilot to maneuver the airplane either up or down to avoid that traffic. It's an excellent system.
But for racing pilots, TCAS has a critical limitation: time. To avoid an oncoming collision, pilots need sufficient time to react to TCAS's instructions, diverting their course. In extremely close-range crashes like Ralph Twombly's, by the time the endangered flyer can respond, it's too late to save his life. The solution? Knowing pilots like Ralph Twombly face dangerous threats like loss of visibility and collision, safety designers wondered if there might be a single device which could save a plane in almost any crash crisis. Today, there is. In the most dire emergencies, when all else fails, a falling plane can deploy its own parachute. After years of research and crash test experimentation, designers mastered the mechanics of plane-sized parachutes, stopping deadly free falls in their tracks. Here's how they work. Like a giant, high-powered version of human parachutes, when a plane is in trouble, a pilot pulls a lever in the cockpit, igniting a rocket launcher which blows open a special storage hatch, releasing the 55-foot parachute. Downsizing a disaster of spine-shattering force into the equivalent of jumping off a 10-foot ladder.
So if things start to go wrong and the pilot starts to lose control of the aircraft, they can pull a parachute the same way that if we bail out of an aircraft, we can pull the parachute. The difference is one parachute takes a pilot to the ground, the other parachute takes the entire aircraft and all of its occupants to the ground.
As engineers continue to experiment with parachute deployment techniques, materials, and proportions, the life-saving devices may someday become common, even in low-altitude racing, helping to stop tragedies like Ralph Twombly's before they strike. Since man could fly, he's flown faster and faster, setting speed records, pushing planes to the limits of endurance. But without the technology of perfect aircraft control, for one experienced flyer, the quest for speed landed in disaster.
The great racing genie wants to see if you have what it takes.
Yeah, well, she's testing me to my limits.
September 1989. Utah's Bonneville Salt Flats. 30,000 acres of barren wasteland. Pilot and plane owner John Sandberg gathers with expert engineers, fellow flyers, and supportive family. Their mission? shatter the propeller-driven speed record.
Real proud of my dad. It's something that's been a long time coming, and I guess I'm nervous right now, but at least, you know, and I'm also excited, mixed feelings.
It was the same record that the Wright brothers did, and Glenn Curtis did, Howard Hughes did.
Breaking the 3-kilometer speed record, the fastest time flown by a piston-engine propeller plane, turns a pilot into a living legend. It's a straight course across a 3-kilometer or 1.8-mile distance. To prevent any unfair tailwind advantage, pilots must make 3 runs back-to-back in opposite directions, all below 1,500 feet.
And it all has to be sanctioned by a governing body that can guarantee the accuracy of the speed that was recorded. It's something you really can't cheat doing. You know, it's a speed that every time it got bumped up, it wasn't easily broken.
To take the record, flying a minimum of 529 miles an hour, John Sandberg needs an exceptional plane. On the outside, stretching 27 feet, his custom-built Tsunami looks like a single-seat P-51 Mustang Warbird. On the inside, this unique flyer features mega mechanics made by elite manufacturers. From a maximum horsepower Merlin engine, to Piper Aerostar landing gear, to Learjet brakes, all designed for maximum speed. As Sandberg and the team make last-minute adjustments, they're taking no chances.
I've had several bad accidents in airplanes with engine failures, yes, and survived. I think the biggest thing, the way I feel it, is no matter how much you practice, every situation is unique, and you'd better be willing and able and ready to respond to the uniqueness of the situation, or it's going to be a catastrophe.
In order to maximize their chances of success, the team needs a critical test run. At last, plane and pilot are ready for takeoff. Family and crew watch anxiously from below as John Sandberg and Tsunami lift up and become a blur in the sky.
Sandberg and Tsunami had an excellent chance of setting the speed record because they had an airplane that was very well prepared. It was very fast. John was good in the airplane, and they really had their things squared away pretty well.
Going for the speed record, pushing his plane to the limit, by the end of the test, Sandberg misses the record by only 21 miles per hour. Beginning his descent, Sandberg plans to prep Tsunami for the actual attempt. But as the plane touches down, disaster. Sandberg slams into the runway, bouncing upwards, smashing down with enough force to decimate the landing gear. Unable to control Tsunami, plane and pilot skid across the runway. Spinning erratically out of control, at any moment, the plane could erupt in a lethal explosion. Crew members rush to John Sandberg and Tsunami. To their relief, the pilot's uninjured. Tsunami's crisis is averted. But with the plane's landing gear torn to shreds, their chance at the 3-kilometer speed record is lost. What went wrong, forcing seasoned pilot John Sandberg to crash on touchdown? The first clue comes from Tsunami's sworn mission, flying as fast as possible.
Tsunami was kind of an elegant airplane. It had landing gear components from other types of airplanes put together, and so its landing gear wasn't overbuilt by any means.
Even with streamlined landing gear, Tsunami might have made a successful landing. But there was trouble on the descent.
Sometimes we have to land in a crosswind condition where the wind is coming at an angle other than straight down the runway. That angle requires the pilot to maneuver the aircraft, and sometimes we put a side load on the landing gear. If that side load is exceeded, the landing gear can collapse.
One answer to turbulent touchdowns like Sandberg's is to use stronger landing gear. But for race planes like Tsunami, it's an unacceptable solution. In many cases, to make landing gear sturdier, it has to be bigger and heavier. To a racer, it's extra weight, which can mean the difference between winning and losing. Understanding ambitious racers' need for super speed, modern engineers experimented with another way to help a plane before it got into trouble. They created telemetry, transmissions of information sent from a flying plane to a computer receiver on the ground. With telemetry sensors on board, ground crews can track and record critical details such as a plane's pitch, how level the aircraft's flying, and yaw, its movement left or right. Telemetry tracking also allows crews to radio a pilot if he's flying dangerously off course or about to make a destructive landing.
I love telemetry. It's the greatest thing in the world. What it does for me as a pilot, it allows my ground crew to watch the airplane for me, basically. I can go out and race, keep my eyes focused outside of the airplane, and fly my line, and if something starts to go wrong in my airplane, they'll know it. They'll know it before I can see it in the airplane.
Today, race crews commonly use telemetry systems to tinker with plane mechanics for maximum speed. But in the future, the technology will continue to help driven pilots like John Sandberg avoid lethal landings and break the boundaries of human flight. In a severe mayday, where there's smoke, there's fire. For famous flyer Lyle Shelton, the ability to bring a smoking aircraft down to Earth was a question of technology and a matter of life and death.
I thought, I'm not going to be able to make that runway.
We got a mayday.
September 1992. Top warbird pilots meet again for a tough Reno showdown. Legendary pilot Lyle Shelton currently holds the 3-kilometer world speed record, and he's won more unlimited class races than anyone in air racing history.
We like to win. We like to beat the other guys.
You know that Shelton has never allowed anybody to run first if he can help it.
Behind the all-star pilot is Shelton's celebrated Rare Bear, a modified Grumman F-8F Bearcat, a classic World War II piston fighter plane known for fast climbs, precision maneuvering, and a canopy with 360-degree views. To boost the Rare Bear's competitive edge, Shelton's design team trimmed aerodynamics and outfitted the fighter with a 4,000 horsepower engine.
The Bearcat was probably the best propeller-driven fighter plane of all time.
At the start of the race, the Reno competitors zoom into the course.
Whoa! It was Strega there with Shelton pulling it right in.
Shelton quickly navigates the Rare Bear into second place. As the flyers head into the final laps, the pilot plans an aggressive charge ahead.
I don't know how long they can keep going at this pace.
When something goes haywire, the Rare Bear starts to hiccup and sputter, losing power fast.
We got a mayday.
The engine popped and banged on me and started quitting when I was down there at 50, 75 feet. So I knew I had big problems with the engine. I started pulling out of the race.
As he maydays to ground crews, Shelton's luck takes a turn for the worse as the stricken plane starts streaming smoke. Desperately trying to keep the Rare Bear in the air, Lyle Shelton opens the cockpit's overhead canopy, anticipating the worst.
Sometimes you have to use a parachute. If you know there's fire and it's getting worse and coming through the firewall, then you want to get rid of your canopy and jump out.
He's in trouble.
Flying away from the course, with the ground coming up fast, Shelton faces a sickening reality. The only runway possible is a life-threatening obstacle course.
That runway was officially a closed runway and had not been maintained like the open runways.
Pounding down the pockmarked runway at nearly 140 miles per hour, bursts of smoking rubber explode from the Rare Bear's landing gear. Careening out of control in a powerless plane, Lyle Shelton makes a final attempt to stop the aircraft.
If you're going too fast and you're about to run off the end of the runway, you can stomp the brake and the rudder, and we call it ground loop. Ground loop the airplane, come to a pretty quick stop.
What went wrong, sending the ace flyer and powerhouse plane into a near-lethal crash landing? The first sign of trouble came from the sputtering engine.
When you're running top speed and the engine hiccups, that's bad trouble. You're probably not going to be able to finish another lap or another few seconds.
Then, the sudden smoke revealed a deeper danger, a spreading fire.
If you know there's smoke and there's fire up front, you want to get the airplane up and out of there.
Inside the Rare Bear, a critical connecting rod had broken loose, severing the engine, spilling hot oil across scorching metal and exhaust. As flames began to shoot out of the plane's exhaust stack, the Rare Bear's engine was dying fast. In this dire situation, even an accomplished pilot is in serious trouble.
Sometimes, it'll kill you before you can get out of the airplane or get it on the ground, just depending on what's broken or what's burned up in the engine compartment. If you burn through an oil hose or burn through a fuel hose, you're going to be in trouble.
The solution? Extinguish smoking fires before they spread. In the past, onboard fire extinguishing chemicals were physically heavy and toxic to the environment. So modern-day scientists set their sights on creating a new substance that was both lighter and safer. After extensive testing, cutting-edge chemistry made it possible with a solution called Fostrex, a powerful chemical agent which consumes fire on contact.
In order for a fire to burn, you need a source, you need heat, and you need air. So if we take any one of those away from that, then the fire is not going to burn any longer. When you spray that on, it's going to take the air away from the fire. It basically smothers the fire.
Instead of merely attacking a fire's oxygen supply or its burning fuel, Fostrex actually changes the whole chemistry of the fire itself. Here's how. Released under intense pressure from canisters stowed strategically in the fuselage, Fostrex molecules attach to a fire's hydrogen molecules, transforming a raging blaze into harmless gas that leaves the ozone layer intact.
5, 4, 3, 2, 1. Discharge. Temperature's coming down. Fire's extinguished.
Plus, the revolutionary chemical is so effective, mere teaspoons of it can put out fires in 1/10 of a second, long before the pilot would ever see smoke. Now approved by the Federal Aviation Administration, groundbreaking chemistry like Fostrex can help protect the planet while saving countless lives from deadly fires in the sky, including daring pilots like Lyle Shelton. Since the dawn of human flight, we've raced, set extraordinary speed records, and performed breathtaking airborne stunts. But in the eternal quest for victory in the skies, survival depends on the breakthrough technology that keeps daring pilots from paying the ultimate price, fueling the crash science of extreme aviation.
You try to push everything to the limit, but you still have to land, you still have to get out of your airplane and walk away after the race.